Hi everyone. So today we will look at 13-4, the sine function. Okay. So previously we've been working with the unit circle. Okay. And I drew it right here. And we used the unit circle to find sine values and cosine values. Okay. So remember for different angles, we found that the x position was cosine. The y position was sine, right? And that's what we're going to be looking at today. So, however, now we're going to be working on graphing this function right here, all right? So we're going to be looking at, for example, y equals sine theta, which is kind of the basic graph. So what does that look like, okay? So to start it off, I drew a basic graph like this right here, okay? So we're noticing that, we're starting at 0, okay? There's a 0 right there. Let's draw it right in. Starting at 0. And just like the unit circle, we're rotating around. So we're starting at 0, and we're rotating around all the way back around to 2 pi again. So we, for example, we go to 0, pi over 4, pi over 2, pi, 3 pi over 2, 2 pi, which is the same thing as 0. Okay, and remember, what are the sine values? The sine values are just the y. Okay, so if I'm creating a graph here, if I start at 0, what's my y? Well, I'm at 1, 0. So I'm starting right at 0. So I'm going to put a dot right there. So there, right there, okay. And then I rotate a little bit more. Let's say I go to pi over 4, for example. Well, that's square root of 2 over 2. That's about a 0.7 or so. And so pi over 4 is right in between 0 and pi over 2. So where's 0.7? So I'm going from -1 to 1 on this graph. So, it'd be roughly right about, we'd say right about there, so, okay? And we keep on going. Next up is, we keep on rotating. We get to pi over 2. Well, look at the y value there. It is 1. So I'm going to put a 1 there for pi over 2. Right there. So I'm going to draw that in. And we're going to keep on going, okay? So notice, now that we're past pi over 2, what's happening to y? Well, y is decreasing, and it actually goes back down to 0 at pi. All right, so at pi, I'm going to put another dot there, and we're just going to kind of fill in the curve. Right there. And okay, so this is kind of the top half of our curve right there. So it's going up and going back down again. Now, you notice it kind of does the same thing, only negative, as we keep on going. So as we rotate around, now we're getting to negative y's. So we're starting at pi. We rotate towards 3 pi over 2. We see y gets negative, and eventually it gets to -1. Okay, so I'll sketch that in. So I'm put a dot right at where 3 pi over 2 and put a dot of -1. And finish it up. Keep on rotating. 3 pi over 2. To about back to 0 again. Okay, so y is getting less and less negative until we're back at 0. We're back where we started. Okay, and again, it's kind of sketching this in. Now it's smooth. It's not pointy at all. I'm not drawing this very good. I won't do that. I'm trying to. Now it's kind of a smooth, kind of rounded curve. I'm not doing this super well, but you get the idea. The book has better graphs in there, and they're probably a bit more representative. Okay, so right there is our basic sine curve. So what we drew right there is the graph of y equals sine theta from 0 to 2 pi. Okay, and with these curves, what happens is they keep on repeating forever. Okay, so. And they keep on repeating the same pattern over and over again. Why? Well, because we're just keep on rotating around this unit circle over and over again. So it's just the pattern just repeats into infinity, basically. So if I kept on drawing this guy, well, look, it just keep on looking like that, and it just keeps on repeating the pattern. Okay. Now, if you wanted to look up values, for example, what is the sine of pi over 4? Well, you can basically just look at the graph and try to figure it out. Where's pi over 4? Well, it's right in between 0 and pi over 2. And we already discussed this one. It's right about there, right? So what y value is that? Well, it's about a 0.7 or so. 0.707 to be exact. But yeah, so that's about a 0.7. Sine of 5. Well, this is a little tricky. Where is 5? Well, if you think about it, if you convert it back into, not pies, not degrees, but you just kind of remember pi is about 3.14. So we're definitely going to be past 3.14. 2 pi is a bit over 6. And if you calculate out 3 pi over 2, it's about 4.7 or so. So we're going to be just a little bit past that. So if we're a little bit past the 3 pi over 2 and kind of go down, well, where is that? You just have to eyeball it. And I don't know, maybe like a negative 0.8 or something like that. You could just punch this into your calculator too. Make sure it's in radian mode, and you could check. And I'll do that. I'm going to plug it into my calculator. And let me see, go to mode, make sure it's in radians. So I can quit. And I'm just going to do the sine of 5. Oh, okay. It's actually a lot closer. It's actually much closer. It's more closer to, I was just eyeballing it. But if I go to calculate it by hand, it's actually much closer to negative 0.96. It's actually pretty close to negative 1. And so it's off by a bit. But don't worry about it too much if you're just trying to estimate it by eye. As long as you're within like a 0.1 or 0.2, that's fine. So that is the basic sine graph. Now, what we're going to be doing, though, is we're going to be kind of modifying this graph and working with the equation a little bit. So the equation we're working with is this one right here. Y is equal to a sine of b theta. Okay, and so the a and b stand for different things. A, in more particular, the absolute value of a is what's known as the amplitude. All right, that's the height of your curve. So notice with this curve right here, the basic curve, well, what's my a? I don't see a number. So that means my amplitude is 1. And that's the height of my curve. That's why, if I'm looking at the graph right here, how high does it go? Well, it goes up to 1, goes down to negative 1, goes back up to 1, right? So it's always bouncing back and forth between 1 and negative 1. It's basically the height of your wave function. Okay? B is the number of cycles between 0 and 2 pi. Okay? What is a cycle? A cycle is one complete graph. Okay? And I drew one cycle for you here in red. So if I start at 0, go up, go down, go negative, go back up again. So I completed one complete pattern of the wave function, of the sine function. That is a cycle. Okay? So this one, if I think about it, from 0 to 2 pi, how many complete cycles do I have? Well, it's exactly 1. Okay, so the b of this one, the basic function, is also 1. So in this one, a is 1 and b is 1. And finally, the other thing you need to be aware of is the concept of the period, all right? All right, the period is the length of one cycle, okay? And so for this one, it's 2 pi, always going to be 2 pi over b. Well, for this curve right here, my period is 2 pi over b, 2 pi over 1, or 2 pi. Okay, what's that mean? My period is 2 pi. That means the length of one complete cycle from beginning to end, going all the way up, all the way down, and back to where I started again, is 2 pi. Okay? Now, we're going to be modifying a and b, though. So let's see what happens when you do that. Okay, scrolling down a bit. And let's look at 15 and 19. Okay, so here you're given an amplitude and a period, and it's asking you to sketch one cycle of the sine curve. Okay, what does that mean? Okay, so basically we have to draw it out, and drawing it out is not that bad. Basically it's always going to follow a very similar pattern. Put a draw. So here we go. I always started off looking like this, okay? Amplitude determines how high the curve goes. So I know it's going to go from 2 to -2. Always starting at 0. And I know the whole period is how much I need to draw. So I know I can draw the entire thing from 0 to 2 pi over 3. Well, what's half of 2 pi over 3? It's 2 pi over 6. Okay. Now, and remember, sine curves are very consistent. They always have the same kind of basic shape. You can kind of stretch them out or make them taller or shorter, but generally speaking, they always start right at 0, right? They go up. In the middle, they always go back down to 0 pretty much. And then they go down negative, and then they go back to where you started. And you can kind of just sketch in, nice smooth. It's not pointy, so just like that. Okay, and there you go. That's all you need to do. Okay, let's look at number 19. So let's see here. Oh, I was also writing an equation. All right, I drew it, but let's write an equation. So on this one, let's see here. Amplitude is 2. That means A is 2. Period is 2 pi over 3. Well, remember that the period is always equal to 2 pi over 3 is going to be equal to 2 pi over b, because that's what the period is always equal to. Okay, well, what does that mean? That means my b is got to be 3. And now I got a and b. It's easy to write the equation. So that's y is equal to 2 sine of theta. 2 sine 3 theta. Okay, let's take a look at the next one. Amplitude of 1, period of 2. Okay, similar deal. Started out, they're going to look always very similar to each other. You just have to be careful about the labeling. Amplitude is 1, so it's going to go up to 1, down to -1. Period is 2, that's one complete cycle. Of course, 1 is right in between 0 and 2. 0 is right there. And draw my sine curve. Again, always kind of follows the same kind of shape. And it's going to be a little messy, but you get the idea. Just like that, okay? So make sure you label your axes correctly, though, okay? For these types of problems, that's what's really important. Okay, now writing my equation. Let's see what I got here. Amplitude is 1, A is 1. Period is 2. So I know 2 pi over b is equal to 2. I'm just going to multiply. So 2 pi is equal to 2b. Okay, that means b's got to be equal to pi. So my equation is y is equal to 1 sine, I'm not going to bother writing 1. So sine pi theta. Okay, there you go. Let's keep on going. Look at some of the later problems. For example, 21 and 26. So they're giving you the equation, and what are they asking you to do? Sketch one cycle of the graph. Okay. So to sketch a cycle, you need to get the A and B parameters, basically. So with this one, well, let's start with 21. 21 here. I don't see a number in front of sine. That makes it easy. So that means my amplitude is going to be 1. A is 1. And really, you have B right here, right? Oops. You have B. I know B is equal to pi. Okay, but b is not what you put on the graph. The period is what you put on the graph. Okay, so I need to find the period, and that is always equal to 2 pi over b, which in this case is pi, so a period is 2. Okay, now I got everything I need to sketch. So again, very similar setup, like that. Starts at 0. Amplitude is 1. Going out to 2. So there's 2. 1's in the middle. And sketch it in from there. So put something there. I always like putting dots in just to guide myself a little bit. Doing it freehand can be a little bit hard. So there you go. And back up again for one cycle. Anyways, we'll get 26. One more. Now this one, this one's a little tricky. Notice there's a negative, okay? So what that means is you're going to need to flip around the curve. You're going to be reflecting around the x-axis. My amplitude, however, is still 4, but I have to remember that it's the curve is negative overall. So I'll write that out. Well, A is equal to 4. B is equal to 1/2. Period is 2 pi over, plug that in, 1/2. That is 4 pi. So this one's stretched out. All right, sketching it. Okay, so there we go. There we go. So amplitude is 4, which means it goes from 4 to -4. Period is 4 pi. Putting that over here on the right. And so 2 pi is going to be in the middle of that. All right. Now, sketching this one in, I got to remember that negative. So rather than going up first, this curve will go down first. So that means I'm going to be going there. Always starting at 0. But I'm going to go negative first and then positive because reflected. All right, and sketch it in. So that's what the negative does right there. One more question. Let's look at 29. This one, go ahead and take a look at the problem. I'm not going to draw it out again. But basically the question is asking you to find the period of each sine curve. Okay, so let's look at 29. Well, how long does it take to do one complete wave of the graph, all the way up, all the way down, and back to where you started? Well, you see from 0 to 2 pi in 29, it actually does that twice. Okay, and you can see, well, where it is in the middle of that, it looks like it does one complete cycle at pi. Okay, so that means your period is pi. I'm just going to write that out. Period, because that's how long it takes to do one complete graph. Is equal to, not 2, it is pi. All right, good deal. All right, so the period is pi, then it asks you to write an equation for the function. All right, easy enough. I have my period. Now I just need to get A and B. If I look at the graph, I see it goes between what and what on the graph. It looks like the top of it actually goes a little bit past 2. Looks like it to me about what, a 2.5? And so, again, you have to eyeball it a little bit. And so I'm looking at this question right here, and I'm going to say, okay, A is 2.5. Now I got to get the period. Well, remember, that's always equal to 2 pi. Sorry, I have to get B. The period is always equal to 2 pi over B. And so I was going to multiply, move the B over, so I know pi B is equal to 2 pi. That means B has to be equal to 2, and that's all I need. So Y is equal to 2.5 sine 2 theta. Okay. Theta, again, is just a variable. It's just like x, basically. We could use x or y or z. It's just very commonly used in trig functions. But it's just another variable, so don't want that to confuse you. Now we're going to be doing cosine and tangent a little bit later on, but they follow very similar rules, okay? Particularly cosine. Cosine is very similar to sine, okay? So if you get this one, I think you find cosine and tangent to be easier once you understand sine. Okay. So let me know if you have any questions, and please do your best to work through this, and I'll talk to you guys later. Thank you.